Good evening, everyone. I extend a very warm welcome to all the participants who have gathered here for this online FDP. Before we commence this FDP, let me play a video of our college, St. Joseph's College of Engineering, OMR, Chennai.
Madam?
Yes, sir. We'll start the FDP. Good evening, everyone. This is Dr. Teresa Jennifer from the Department of IT, St. Joseph's College of Engineering. I extend my warm welcome to the ATAL Online FDP, Recent Trends and Future Directions in AI for Medical Imaging, jointly organized by ATAL and IT Department, St. Joseph's College of Engineering, OMR, Chennai. First of all, let us extend our sincere thanks to the ATAL AICTE Teaching and Learning Academy for selecting us to conduct this 6 days online FDP, which is the second online ATAL FDP that the Department of Information Technology is organizing. I thank our Honorable Chairman, Dr. B. Babu Manoharan Sir, our Executive Director, Ms. Jesse Priyamam, our Managing Director, Mr. Shashi Shekhar Sir, our Principal, Dr. Vaddi Shesagari Rao Sir, our Dean, School of Computing, Ms. Lata Selvi Ma'am, and our HOD and Coordinator for this FDP, Dr. Helton Janita Ma'am, for being a constant support to conduct this event. I also extend a warm and sincere welcome to all the participants from various colleges across India and our esteemed resource persons joining us for this online faculty development program. We are delighted to have your presence and look forward to an enriching and engaging learning experience together. May I now respectfully invite our esteemed principal, Dr. Vaddi Sheshagiri Rao sir, to share a few words and address the gathering. Our principal sir will connect in a few minutes. Let me read the FDP guidelines meanwhile. Artificial intelligence is revolutionizing medical imaging by enhancing diagnostic speed, accuracy, and early detection, supporting clinicians in delivering better patient care. The focus of this FDP is to provide the participants with a comprehensive understanding of emerging AI based techniques and tools in medical imaging, enhancing their technical and analytical competencies. Here are some of the guidelines for this online ATL FDP. Active participation is expected throughout the session on all the 6 days. On day 6, an online test will be conducted. Feedback attendance link will be shared anytime during or at the end of the session. So always stay connected to the session. Please make sure to maintain 80% attendance. E-certificate will be provided only for active participants identified based on attendance, feedback, submission, and performance in online test, scoring a minimum of 70% marks. You can post your queries in the comment section during the session. It will be answered at the end of the session.
Madam, you started, madam?
Yes, sir. Yes, sir.
Okay, okay. Actually, there is a poor connection. That's why I could not join now. Now I have joined. Dear colleagues and my dear participants, So welcome to this online ATAL FDP. First of all, I thank I thank the authorities of ACT and ATAL for giving this chance. This is the second time, as Madam has told, this is the second time we are conducting. Department of Information Technology is conducting second time. So we thank the authorities of ACT. And this, especially this AI in medical field, it is playing a vital role. Definitely this online FDP will help in disseminating the knowledge that is required for the students. We have arranged experts from various fields in this particular domain. So I request all the participants regularly, please attend the entire session, all sessions, and get the knowledge. That's what my sincere request to all of you. And definitely AI in medical imaging process is having a vital role, and especially in course of time, people are saying replacement of doctors also, they are getting replaced with the new technology. So this particular AI in this medical imaging process will be much useful for the next generation. So I request all of you, please be regular. Thank you, madam. Madam, you please
Thank,
proceed, madam.
thank you, sir, for your words of wisdom. Now I request everyone to kindly switch on your camera so that we can take a group picture. Kind request to all the participants, kindly switch on your cameras so that we can take a group picture. Thank you, everyone. Now we can switch off your cameras. It is my pleasure to welcome our Honorable Head of the Department, Dr. Hilton Janita Ma'am, to offer a few words on this occasion and start the first session of day one.
Good evening to one and all present here. On behalf of Information Technology Department, St. Joseph College of Engineering, I am delighted to welcome you all to this online faculty development program on recent trends and future directions in AI for medical imaging. This FDP aims to provide faculty and researchers with a deep understanding of how artificial intelligence is transforming the field of medical imaging from early disease detection and image enhancement to faster, more accurate diagnosis. As healthcare increasingly integrates intelligent technologies, it becomes essential for us to stay updated and equip our students with the knowledge and skills that the future demands. I extend a warm welcome to our distinguished resource persons who will be sharing their valuable expertise throughout this program. I also welcome all the participants from various institutions for taking the time to join us. Your presence reflects a strong commitment to continuous learning and academic achievement. We hope this FDP will enrich your perspective, encourage collaboration, and inspire new directions in teaching and research. Now, I would like to welcome Dr. T.M. Inbamalar ma'am, who's a professor in the Department of Electronics and Communication Engineering at RMK College of Engineering and Technology, Chennai. She has over 28 years of teaching experience. Dr. Inbamiller has been recognized PhD supervisor at Anna University since 2017 and has successfully guided 4 doctoral scholars. She continues to mentor research scholars in areas such as medical imaging, cognitive radio, and advanced communication technologies. She holds 3 granted patents and 6 published patents from the Indian Patent Office. To date, she has authored 82 research publications in international and journals and conferences. As accomplished speaker, Dr. Inbamiller has delivered over 36 guest lectures and chaired technical conferences. She has secured prestigious grants, including those from TNSCST, SERB, and AICT for projects, seminars, and faculty development programs. Her successful consultancy projects and automation and IoT applications further demonstrate her industry engagement. Dr. Inbamala Mam's contribution have been recognized with numerous rewards such as Young Woman Scientist Award and multiple Best Paper Awards at international conferences. Over to Inbamala Mam. Ma'am, kindly take over the session.
Ma'am, am I audible? Am
Yes,
I audible?
ma'am.
Yes, ma'am.
Shall I share my screen?
Yes, ma'am.
Ma'am, whether my screen is visible?
Yes, ma'am.
Shall I start, ma'am?
Yes, ma'am.
Good evening, one and all present here. Thank you, Heltin ma'am, for a nice introduction. Actually, the topic given to me is machine learning and deep learning, fundamentals for medical applications. So I am supposed to deliver the fundamentals of machine learning and deep learning, which are used for biomedical applications. So the outline of my session is, I have divided it into 4 sections. In the first section, I'll be telling you about the principles behind artificial intelligence, machine learning, deep learning, neural networks, and generative AI. Then I'll be moving to the general medical applications, and I can tell you few real-time examples. And finally, I'll conclude with the future trend. So this is how I have planned my session. And all of us know today the trending topic is artificial intelligence. Wherever you go, whether it is a engineering institution or school or agriculture or social needs, wherever everyone speak of the term artificial intelligence. But you see, this artificial intelligence started in the year 1950s. So the concept of artificial intelligence is machines exhibiting human intelligence. So This basic concept was introduced in 1950s and it was in use. Later, in 1980s, people started developing a system where machine can learn from the historic data. So this is actually a part of intelligence where machine is getting intelligence, which means it is learning from the historical data. So basically statistics is incorporated in this, and since machine is learning, it is called as machine learning. Later in 2010, we are moving to another concept where we create some network which can replicate the human brain function. And we called it as neural network, and the network which uses this, we call it as deep learning. So intelligence created artificially, statistical learning by machine, then learning by a network similar to a human brain by a machine. So this can go into deeper than machine learning. So we termed it as deep learning. So this three comes under one sector, and recently in 2020s, we have gone to a different concept, different in the sense which is different from both machine learning and deep learning, where the AI could create on its own without learning, which is called generative AI. And today the talk of the day is generative AI. So now you could see it took 75 years for a concept called artificial intelligence, which came into practical existence, and now everywhere artificial intelligence is required, whether it is the movie, or it is a technology, or it is an online education, or it is a Google search engine. Everywhere we have the artificial intelligence. And particularly, I'll be giving a focus for medical applications in the later part, as I have told you in the beginning. So now I'll give a small intro about artificial intelligence. So all of us know it is a technology where machine is acquiring intelligence. So the term intelligence acquired by a machine artificially. So this intelligence it is acquiring, like it can learn, it can reason, it can make decisions. So generally learning, reasoning and decision making are the process in artificial intelligence. So machine learning means it requires algorithms. So when it requires algorithms, it needs data. So the requirements for an artificial intelligence system is algorithms, data, and you need some processor to simulate this artificial intelligence. That is, the human cognitive functions are artificially simulated in a machine by using certain algorithms which work on data. So we have to note this data plays a major role in artificial intelligence. So as I told you already, its application is everywhere. For example, in the Google search engine, voice assistants, we have autonomous vehicles. Wherever we go today, we have the artificial intelligence. So here we make the machine think, learn and make decisions like human beings. So it can solve problems logically, it can learn the past and it can improve performance. It can understand images, it can understand audio, and even it can understand the environment and decide based on that. So it can understand the language and it can communicate in human language. For example, today we have the Alexa, where we are communicated like a human being. So the Siri, Alexa, all comes under this language understanding and communication. And then this, when we receive the emails, it is automatically filtering the spam. So in the email, we have spam filters, which is an application of artificial intelligence. Like there are many day-to-day applications. So this AI is in everyday life, but this AI can be divided into three. First one is narrow AI, second one general AI, and third one super AI. So I told already, we took 75 years to practically use AI, and the literature says only narrow AI is in existence. So narrow AI means it can do only specific tasks. For example, the task what I have told already, like voice assistant, the spam filters, autonomous vehicle prediction, etc. Such specific tasks can be done as the artificial intelligence system, which means what are all the artificial intelligence system which we use in our day-to-day life all comes under this narrow AI. And the next category, general AI, is hypothetical today, because a machine, it is learning, it is predicting. It is not equivalent to the human intelligence as of now. So this general AI is equivalent to the human intelligence, which people are aiming to achieve and working. And the third category, super AI, which is like fiction. It is futuristic. It is beyond human intelligence. So you see, we achieved some part of human intelligence and we are aiming to achieve equivalent to human intelligence. And we want to go beyond human intelligence, which is like fiction nowadays. So now we know there are numerous benefits of artificial intelligence. A repetitive task, it can perform automatically. It can do it more faster and it can provide more insight to us from the existing data. It can make decision fast and the errors, human errors will be very minimum, and a human cannot work for 24/7, but this AI will be available to us for 24/7, and this reduces physical risk. So now this artificial intelligence have two counterparts. One is machine learning, other one is deep learning. So you see, machine learning, learning by the machine using statistical data. The decisions are statistics oriented. The second one is learning by the machine using an interconnection of neurons, which is deep learning. So now let us see these two in detail. First, let me start with machine learning. So again, whether it is machine learning or deep learning, we are going to make the machine intelligent. So we need algorithms which the machine could understand. So here we will be developing algorithms that can learn patterns and make data-driven decisions, or it can predict. So you see, the input is the data. It go on learning from the data, get trained from the data, it understand the behavior of the data, which means it is learning the patterns, and based on that behavior it is going to decide. So the decision may be binary, it may say good or bad, or the next step is it can go for prediction, this may happen like. So this enables system to learn and improve from experience without being explicitly programmed. So there will be a algorithm developed already and we can use that. So then and there we need not develop algorithm for a particular task. It can perform many tasks. So that is the meaning, without being explicitly programmed. So this allows the computers to learn from data without being explicitly programmed. You need lot of data so that it can learn lot of behavioral patterns, so that it can make decisions without any error. Now this type of machine learning is nowadays used in fraud detection, predicting trends, personalized requirements, and to some extent so far in medical diagnosis. So here we have four types of machine learning. First one, supervised learning. Second one, unsupervised learning. Third one, a hybrid version of supervised and unsupervised, which is called semi-supervised learning. And the fourth one, a different category, reinforcement learning. So if we want to apply this machine learning in a particular medical application, we should understand how this algorithm performs. Then only we can relate to this our required task. So See, supervised learning, you will be having the data labeled. Unsupervised learning, your input data will be unlabeled. So if it is learning from the labeled data, it is called supervised learning. If it is learning from the unlabeled data, it is called unsupervised learning. And if it is learning from few labeled data, it is called semi-supervised learning. So apart from this, if the machine is learning by trial and error using rewards, a different approach, it is called reinforcement learning. So let us see this 4 in detail. First, let me show an example for supervised learning. So you see, I have a small, for illustration, I have taken a small group of data where I have square, triangle and hexagon. And here, while I am making the machine learning, I am labeling, this is a square, this is a triangle, this is a hexagon. Then I am training the machine that this is a square, this is a hexagon, this is a triangle like. Then I'm going to test with the data. So that test data when I give, already it is labeled. So the machine can understand easily and it is predicting accurately. This is a square, triangle like. So here the input data set, what we provide as input to the machine for training is labeled. So it is called supervised learning. So this learning can be related to a teacher and student. So basically learning. So we teachers, we teach our students, they are learning. So I have taken the analogy of teaching a child. So you know, the child will be, when a child is born, it is taught everything, it replicates. For a student in a school or college also, they were taught and they will be replicating. So here you see, we want to teach a child to read. So we show them the correct pronunciation of letters and we show them how to combine and read words to some extent. So this supervised learning, already they were given the correct pronunciation of letters and words and they have to connect together and read. So which means the input given to them is specifically labeled so they can interconnect and read. So this is the analogy to supervised learning. So this supervised learning can be used like, you see this example, you have the input data. Here you have the images of cats and each cat is having a different outlook. So all these are labeled as cats and given to the machine. And now the machine will be tested with some raw data and it will compare it with its land experience and it will decide whether they are cats or not. So it is making a binary decision whether it could correlate with the labeled data or not. So the output or the outcome of this supervised learning will be a binary decision where you could say whether it is cats or not. So when come to practical application, whether it is normal or abnormal. So it is relating to classification. So one type of problem that can be solved with this supervised learning is classification. So classification means you will be sorting the input data into 2 categories. So you will be sorting the input data into 2 categories. The other one is regression. You will be identifying their real values, their quantitative measures. So supervised learning can be applied to 2 types of problems. One is classification problem, other one is regression problem. So classification problem, the goal is to train the prediction of a category, and there you will be having linear classifiers or decision trees or logic regression. So logic regression means it is the binary regression where the output will be yes or no like. So in the output they assign a specific label or class to each input. You will be giving an input, it will be labeled yes or no like. So coming to the regression model, the goal is to predict a quantitative value. So they work by predicting a continuous value based on the input data. Here the model adapts the internal parameters. So they predict a continuous value based on the input data. So here we will be assuming a error function. We need the accurate value. So we will be calculating the error between the actual label and the predicted label, and this go on learning till the error becomes minimum. So this is the regression pattern. So for optimizing, normally gradient descent algorithms are used. So basically this is a iterative procedure where the loss function is minimized. And practically, if you have 1,000 data, 80% of the data you will be using for training the network, and 20% you will be using for testing the data set. Then you will be finding the performance metrics, and if you are satisfied with the performance, then you will be fixing that algorithm. So you see, if you go for a classification task, you will be measuring accuracy like parameters. And if you are going for a regression task, you will be measuring mean squared error like parameters. So based on this parameter evaluation, you can finalize how well the model works. So I told already, you'll be having algorithms, and coming to supervised learning algorithm, we have linear regression. So linear regression means you'll have a straight line. So the input will be predicted whether it is above the straight line or below the straight line like. So in one axis you will have the input, in other axis, normally in x axis you will have the input, and in y axis you will have the output, and the straight line starts from the origin, dividing that quarter into two halves, and the inputs which have similar parameters will be put on above the straight line, others below the straight line. So it will be categorizing into yes or no pattern. Logistic regression, exactly yes or no type answer. Linear regression, a quantitative measurement. Then decision trees. So the model makes decisions by asking a series of simple questions. It is like a flow chart. It is easy to understand. Then support vector machines. So this have many practical applications. Normally SVM classifier we use in most of the case, most of our research works before 10 years. So this tries to draw the best line, a best boundary to separate different categories of data. Next, K nearest neighbor. This will be measuring the distance, and it will be accumulating the closest data points. So that is why it is called nearest neighbor. Then naive-Bayes theorem, where they will be classifying things based on probability. Random forest algorithm. So it builds lot of decision trees and combines them for better accuracy and stability. So I'm not going to say in detail about these algorithms because each algorithm will be having their own steps, and I'll be telling you the concept so that in your practical requirement, in your research problem, based on the concept, you can select which algorithm will work for your problem on hand. We know advantages: high accuracy, performance optimization, prediction. It will make direct predictions. And coming to the limitation, it needs to deal with huge amount of data. So it requires significant time for data labeling, because supervised learning, we have to label the data. We have to train with labeled data. So this labeling data also takes significant time. So this slow down the learning process, and the entire process consumes time. So I know the problems what me along with my research scholars took. Our program run for 2 to 3 days, biomedical images. So this is one drawback. Next, because of this labeling large data sets, this is expensive. Then it is limited to the patterns specified in the labels. So you see, it is like replicating. You are teaching the machine that this is this length. So it can replicate only what is taught to it. It cannot decide with its intelligence. So it is limited to the patterns specified in the labels. This means the models may not be able to detect new or unexpected patterns. So when you provide many unexpected patterns, it cannot decide, it will wrongly classify, which will lead to inaccurate output. So these are the limitations in supervised learning. Next, we move on to unsupervised learning. So here it is like building a model on an unlabeled data. So your input will be unlabeled data, and you will be finding patterns from that unlabeled data, which means the behavior you find from that unlabeled data. So you'll be having algorithms which can analyze unlabeled data to find hidden patterns, structures, and relationships without any prior guidance. It is not trained like this is cat, this is dog, this is apple like. It is using its intelligence and it is predicting. So there is no need of human labeled data sets. So the drawback of previous supervised learning is it consumes lot of time in labeling the data. So here that problem is removed. There is no need for human labeled data sets. So I have given an example. You have the mixture of circle, square, triangle. It is not labeled and it is given to your unsupervised learning algorithm. It learns on its own and it classifies similar categories. So again, let us come to the teacher-student analogy. Here, previously, we taught the child the known language, pronunciation, words. It replicated. So coming to this unsupervised learning, the child is put in a new environment where everyone speaks a different language which is unfamiliar to the child. No teacher or no directory available at the moment. The child starts observing, the child starts listening, and the child is independently establishing connections to understand. The child pay attention. So it is watching the tone and emotion of the voice, and it watches some phrases with great excitement, some phrases with pleasure, some phrases with sadness, and it associates everything and it is coming to a conclusion and it starts talking. So this is unsupervised learning. So here the unlabeled data given to the network, trained, processed, and on its own intelligence, it is predicting whether it is a square, triangle like. So now you see, let us come to the cat example. So here you see the input consists of cat as well as some other pictures. It is uncategorized, not labeled. It is given to the machine. The machine observe and learn from the patterns. And here you see, it is combining similar groups. So the child is combining emotions like happy, sad, like. So similarly, in the unsupervised learning, this machine is combining similar groups. So the cat pictures, it combined into one group, and the other pictures, it combined into other group. So when we come to our real-time problems, this is similar to clustering, identifying similarities in groups. So it analyzes the pattern, and similar pattern, it forms into single group. Hence, it is called clustering. So another type of application is anomaly detection. So there will be a similarity for the normal behavior, and when there is a unwanted behavior, it will be distinct from the normal behavior. So that different pattern it can identify. So this unsupervised learning can be used for anomaly detection. So coming to our biomedical application, both clustering and anomaly detection have a huge demand. So it will cluster like this, different groups it will combine. So here the data is not usually divided into training sets and test sets as it is done in supervised learning. So when we go for the supervised learning, if you have 1000 data, first you will decide this 800 data I am going to use for labeling. This 20% data I am going to test. Then I'll find the accuracy like. Here we need not do like that. So here for example, clustering normally k-means algorithm. Then the second type is associative rules mining, which means it is finding the relationships or patterns between individual elements of data. Here we go for the probability based a priori algorithm. Then the third one is very important, dimensionality reduction. So we know we have to deal with huge amount of data. So huge amount of data is the bottleneck in all our algorithm development. So here this unsupervised learning can be used for dimensionality reduction, which simplify the data while retaining the important information. Your data will be simplified, but the information will be preserved. For example, principal component analysis. So this is the algorithm that transforms large set of features into smaller sets while retaining the required information. There are many unsupervised learning algorithms available in the literature. If you take clustering, you have centroid-based methods, distribution-based methods, connectivity-based methods, density-based methods. Under centroid-based methods, we have the k-means clustering and fuzzy c-means clustering. So this we will be studying in our textbook itself. Then coming to the distribution-based methods, we have the GMM, Gaussian mixture models, expectation maximization algorithm, Dirichlet process mixture models. Connectivity based methods, hierarchical clustering, agglomerative clustering, divisive clustering, affinity propagation models. Then density based methods, we have density based spatial clustering of applications with the noise. Then we have the optics. So you see, normally when we go for a research problem, we will be identifying a problem in our hand, and we have to look into the problem in such a way whether we have to go for classification or whether we have to go for clustering. Like when we decide that we are going for clustering, we can select the algorithms in this group. If you want to go for finding the patterns between items in large data sets, for example, market based analysis and all, we have to go for the association rule based learning algorithms. There we have to go for the a priori algorithm, frequent pattern growth algorithm, equivalence class clustering, and bottom up lattice traversal algorithm. Then if we need dimensionality reduction, we need to apply principal component analysis, t-distributed stochastic neighbor embedding, non-negative matrix factorization, independent component analysis, locally linear embedding. So the first thing is we should be clear what we have to do with our data. We should not simply try with the algorithms in the literature. Normally when we go for image processing and all, we have to study the behavior, that is pattern of the image, and accordingly we have to select the processing algorithms. Similarly, here in the learning methods also, we have to be clear whether we are going to classify, whether our answer should be yes, no, or whether we need a quantitative analysis, we need the weight of the thing, or whether we need to cluster it into different groups, whether we need the compression, that is dimensionality reduction. So that we have to finalize first. Then we could look into the literature and for the data set what we have taken, what type of algorithms are applied, and accordingly we can try with the algorithm. So that is why these fundamentals are required in medical applications. So very important, the advantages, do not require a labeled data. So thereby that labeling task is absent, because of that cost reduced, and this is automatically detecting pattern. So previously known pattern only it could identify. Here there is no restriction, any pattern, any input you can apply and check. The limitations again, especially if you have you see again, depending on the data available with you, you have to decide whether you need supervised learning or unsupervised learning. If you have the data in your hand with label, which means you got a data set where the data are labeled, means there is no need of labeling again. So your algorithm complexity will reduce because no need of labeling. So in that case, if you go for supervised learning algorithm, the efficiency will be more compared to unsupervised learning. Instead, if you get unlabeled data, don't try with the supervised learning. Directly you go for unsupervised learning. So unlabeled data is with you means accuracy will be more in unsupervised learning, and labeled data is with you means simply you can go for the supervised learning. So another thing is, unsupervised learning is not good for prediction. So unsupervised learning is good for data analysis when working with a large data set where labeling may be impractical or costly. So now let us compare. We know supervised learning for labeled data, unsupervised learning for unlabeled data. The goal is here classification in supervised learning. In unsupervised learning, we can discover hidden patterns, unknown structures, or groupings we can do. If you see the computational complexity, supervised learning is less complex as the model learns from the labeled data. Unsupervised learning is more complex because the model must find patterns without any guidance. Here you can apply this for classification or regression. Unsupervised learning you can apply for clustering, association, and dimensionality reduction. Now let us move to the third method, which is semi-supervised learning. So actually, when you have a mix of labeled and unlabeled data, you can go for semi-supervised learning. So here what happens is, this is using a small amount of labeled data with a large amount of unlabeled data to train a model. So it is making use of both the advantage of supervised learning as well as unsupervised learning. So it can be called as a hybrid method of learning. This is useful in scenarios where labeled data is expensive, time consuming, or impractical. So you see, you have a mix of data and it is very difficult to label the data, but you need an accurate output. So what you can do is, a small portion of the data you can label and you can go for the semi-supervised learning algorithm. So it is a hybrid approach. It leverages both labeled and unlabeled data. There is no extensive manual labeling. A small portion only manually labeled. So compared to unsupervised learning, this is cost effective. And here, since it is taking the advantage of both supervised and unsupervised learning, it gives improved performance. So see an example. See the input data. I have in a group apples, banana, orange. But I'm not labeling all three. Here what I do is I partially label, because semi-supervised means only few data I'm going to label. So here I am training banana and orange, which means I am labeling banana and orange. Now I am going for the semi-supervised learning model. The machine is trained, and now I am testing with all the three inputs. I'll give orange, it will predict it as orange. I'll give banana, it will predict it as banana. Both are labeled already. Now I'm giving apple, it is not labeled, but the algorithm, it analyzed the repetitive patterns and it is predicting it as apple. So this is semi-supervised learning. So here, if you see the methods, it includes self-training, co-training, generative models, graph-based models. So self-training, predictions on the unlabeled data. Co-training, co means more than one. So multiple models are trained on different views or different subsets of the data, and their predictions on unlabeled data are used to label each other. So here, self-training, one model, co-training, training, multiple models. Then generative models. So this is generative adversarial networks. We call it as GAN. It learns the data distribution and generates synthetic labeled data. Then graph-based methods, in extrapolation and all. These methods construct a graph where the nodes represent data points and edges represent similarities. So using labeled data to propagate labels through the graph to unlabeled points, like extrapolation. So these are the common methods used in semi-supervised learning. So these are applications in image recognition, speech recognition, text classification. This is useful in medical diagnosis and commonly in fraud detection. So let us summarize. Supervised learning, similar to a student being taught concepts by a teacher both in class and home, always supervised. Unsupervised learning, like a student figuring out concepts independently without instruction, self-learning. Semi-supervised learning, a mix where the teacher provides some concepts in class and the student practices with the homework assignments based on those concepts. So now, I request the participants to see this, and can you tell whether this comes under supervised or unsupervised or semi-supervised? So you can give your answers in the chat box. So it is actually supervised. So you see, you have the input raw data which have camel, elephant, and cow. All are labeled. Cow is labeled, elephant is labeled, camel is labeled. So the input raw data is labeled. Then algorithm predicts the output. So here, since all the input data are labeled, it comes under supervised learning. So I shall move to the next. See, here you have the camel, cow and elephant. So can you now understand what type of training is this? Can you give your answers in chat box? So it is unsupervised because the input raw data is not labeled. So let us move to the third one. So here you see input data, elephant, camel, cow. So here partial labeling. So it is coming under semi-supervised. So now I'll move to the fourth category, reinforcement learning. So this is feedback-based learning method. So here, based on the rewards or punishments, that is based on the feedback, correction will be carried over. So here we introduce a term called agent. This agents learn to make decision through trial and error. So you see, you have the agent who is initiating action. So the environment will change its status. Feedback is given. So this goes like a iterative process. So the agent interacts iteratively with its environment in a feedback loop. So agent go on observing the current state of the environment. As per its rule, it decides and it transfers its decision to the environment. Environment respond, it changes its state to the new state. Again, the agent checks, it updates. Like this, the cycle goes on repeating and finally it comes to a decision. So this is mathematically Markov decision process. So reinforcement learning, basic concept is Markov decision process. So here future states depend only on the current state and action, not on the prior sequence of events. Based on the feedback, it goes on updating. It is an iterative procedure. So you'll be having an input raw data, the combined effect of the agent and the environment, a iterative procedure will group the input raw data. Two types of algorithms are available. One is model-based method, another one is model-free method. So model-based method use a model of the environment to predict outcomes and help the agent plan actions by simulating potential results. So Markov decision process, and we have few more algorithms. Bellman equation, value iteration algorithm, Monte Carlo research. So basically it is a iterative process. Then model-free methods, the agent learns directly from experience by interacting with the environment and adjusting its actions based on feedback. Q-learning, reinforce algorithm, like there are algorithms available. So now let us compare the four. First, let us consider the input data. Supervised learning, labeled, unsupervised learning, unlabeled data, semi-supervised learning, partially labeled data, reinforcement learning, no predefined data. Then coming to the training, supervised, external supervision, unsupervised, no supervision, semi-supervised also supervision procedure, reinforcement, no supervision. Then if you see the uses, supervised is used to classify. Unsupervised is used to find hidden patterns. Semi-supervised is used to improve the performance. Here you see reinforcement, it can learn a series of outcomes. Computational complexity, supervised simple, unsupervised complex, semi-supervised depends, depending on the data which is labeled. Reinforcement, iterative procedure, so a complex procedure.
Out of this window, and that should have fixed any it's working. And lastly, we're going to uncheck this automatically adjust microphone volume, and we're just going to set
So
this
coming to accuracy, higher
out of this
in
window,
supervised.
Fixed any microphone issues you're having inside of Zoom. If you still are experiencing problems, then please drop a comment.
So coming to accuracy, the accuracy will be higher in supervised learning, comparatively less in unsupervised and semi-supervised. Reinforcement, it will be good. So when you have a problem in your hand, you have to decide what type of performance you expect. Whether you go for a complex solution or whether you go for a simpler method. So like this, you should decide the outcome and then you can make a choice of the methods. Now let us come to the challenges. Supervised, we need to label. So pre-processing will be very tough and it is time consuming. If you give a unknown data, it cannot handle. So it is not able to handle complex tasks. Unsupervised, more time required by the user. Maybe it may lead to less accurate solutions, but computationally more complex. Semi-supervised, complex. Your accuracy depends. It cannot handle many complex tasks. Reinforcement, it is a trial and error. It is fast learning. If you give small samples, it is not preferable for simple problems. When you have complex problems, you can choose reinforcement learning. So now, any disturbance from my side, or so I could hear some. Any noises that here? So now we will move to the next, deep learning. So you see, deep learning, different concept. Here we use the neural networks. So deep learning uses artificial neural networks with multiple layers to automatically extract the features from large data sets. Here we can deal with large data sets. Here everything is automatic. If you see machine learning, there is a manual intervention, but when you come to deep learning, it is automatic. So this deep learning works on the interconnection of neurons, which means it is trying to replicate the human brain. So when the computer replicates the human brain activity, it can autonomously uncover patterns and make informed decisions from vast amounts of unstructured data. So you can have unlabeled data. So you can have unlabeled data. From the unlabeled data, you can extract the features. Shall I continue?
Yes, ma'am.
Yeah.
So deep learning, basically a mimic of the human brain. The advantages, it learns from huge amount of data, it can handle huge amount of data. So this is basically neural networks with the multiple layers, which means the interconnection of neurons similar to human brain. So this can learn complex patterns automatically, and the decision performance, the accuracy improves if you have more data. Here you need not apply anything manually. It is handling complex data, whether it is an image, audio, language, whatever, it can handle comfortably. And to give very accurate prediction, it require a large amount of data. So when you go for a large amount of data, your processor should be able to deal with those large amount of data. So you should have a computer or a processor which is having a very good computing power. That also is a requirement here. Otherwise, your program will run for 4-5 days late. So this have applications in almost all the domains. For example, image processing, voice assistant, self-driving cars, etc. And the fundamental algorithms, fundamental learning models are convolutional neural networks, which is the most common one, which is used by everyone. Then RNN, transformers, etc. Here, one important thing we have to notice, the neurons are interconnected. So it is a fully connected network. The data flows through multiple layers. Each neuron is performing a transformation. Each neuron is doing a task. And basically, the neuron do non-linear transformation. So, see, if we come to the architecture, it is divided into 3 layers. The data input part is called the input layer. Then the processing part is called the hidden layer, and the output layer. So the raw data are given to the input layer, and the operation happens in the hidden layer. So here only I told the neuron will be doing non-linear transformation. So the purpose is to extract the pattern, to give the structured pattern. And here the non-linear transformations are defined. That is called activation function. So we have few activation functions. Basically, it is a weighted sum. Then the output is given in the output layer, which can be a prediction or classification. Anything can be done here. So now the neuron performs a nonlinear operation. Its value is compared with the error function, which is called a loss function. So this is a iterative procedure which goes on till the error is minimized. So step 1, it undergoes a transformation, calculate the loss function, weights are updated. Second step, calculation, weights updated. Like, it is a iterative process where the process goes on repeating until the model learns the patterns. So you see, you'll be giving input, then weights, neurons are interconnected, the features are applied as inputs. Then this is a very small example. The neurons are interconnected, each neuron is performing its operation, and you get the output. So I told activation function. These are some of the common nonlinear functions used. Sigmoid function, tan h, this rectified linear unit that we use most commonly in all our projects. We will be telling Rayleigh unit like. Okay. Then softmax used in the output layer of multi-class classification. So like this, we use the activation functions. And let us come to the algorithms now. So the most common one is convolutional neural network, CNN. This is mainly used in image processing. In olden days, the image processing, we call it as image processing. Nowadays, it is renamed as computer vision. Computer vision is also basically image processing. The CNN is good for image processing. So, face recognition, such applications in a general sense you can use. Coming to medical application, we need image processing. So CNN finds most application in medical image processing. Then the second one is recurrent neural network. This can deal with sequential data. So if you are going to work on signals, so you understand, if you want to process image, you select CNN based deep learning structures. And if you want to work on signals, you go for RNN based deep learning algorithms. So this work on signals. So this application is speech recognition, time series. There is time based analysis. Then the recently used one, LSTM. This is long short-term memory. Then GAN, generative adversarial network. AE, autoencoder. So you see, LSTM is also good for signal analysis. GAN is good for data generation. This GAN can be used in image enhancement. But image classification, CNN is good. Then autoencoder is similar to principal component analysis. So it is good for dimensionality reduction. So autoencoder based algorithms you can do when you need to compress the data. So dimensionality reduction application in the machine learning, we will be going for principal component analysis. Here in the deep learning part, we can go for autoencoder. Then transformer is used for natural language processing. We know ChatGPT. It is a natural language processing tool. So like, what is your application? Whether you are going to process a biomedical signal, or you are going to process a biomedical image, or you have a large amount of data, you have to apply dimensionality reduction, then only you can process. Like you have to analyze, or you need to enhance the image, like you have to first finalize, then you can choose the algorithms. And again in deep learning also you can have unsupervised, semi-supervised, reinforcement, transfer. You see, first one is semi-supervised. You know it very well. Then self-supervised learning. The name self-supervised learning means it is unsupervised learning. Here no supervised learning because it will deal with a huge amount of data. So it is basically neuron get trained. So no supervised learning we need. Then reinforcement learning is also here. And you see one more new learning procedure is there in deep learning, which is transfer learning. So here in transfer learning, knowledge gained through one task or one data set is used to improve the performance of another related task on the same data set or different data set. So prior information, prior experience from other tasks can be used to improve the performance of this task. That is transfer learning. So normally nowadays transfer learning is used in many of the research works. So coming to deep learning, transfer learning is an added feature. And ready-made tools are available. Deep learning advantages, ready-made tools are available. We know we work on TensorFlow, PyTorch, Keras, MXNet, Caffe, Piano. So like this, ready-made tools are available. So it is easy to work on the input what we have. So the important advantages, it can handle high dimensional and unstructured data. no manual intervention. It is automated feature extraction. It gives very high accuracy for even complex problems. It is scalable with big data and GPU. Limitations: if you have large data set, then only deep learning will work out. If you are having a limited data set, don't go for deep learning. You stop with machine learning. So first thing in our research also, we know first thing is we have to collect the data set. So based on the data set only, we have to survey the techniques, and accordingly we have to go for the technique. So if you have a large data set available, go for deep learning. Then high computational cost, difficult to interpret, and overfitting risk is there. So this is regarding deep learning. Overall, deep learning is advantageous. If you compare machine learning with the deep learning is advantageous because it is dealing with a large amount of data and gives improved performance. And we are more particular about medical application. So for medical application, compared to machine learning, deep learning only works. So general applications and the present real world examples. We have the Google Lens. Everywhere face recognition is there. In our mobile, we have the face recognition. For attendance in most of the institutions, face recognition is used. So practically, face recognition is employed everywhere, which can be comfortably dealt with deep learning. In real time, object detection, autonomous vehicles, autopilot, that and all, accuracy is more important. So we have to deal with a large amount of data. There we have to use deep learning algorithms. Then speech and natural language processing, this Siri, Alexa apps, then ChatGPT, everywhere we go for the deep learning model. Now you see the hierarchical diagram. The broad sense, artificial intelligence. Under that, you have machine learning. Then you understand, in 1950s, artificial intelligence. In 1970s to 80s, machine learning, which was completely statistical. Then the concept of neural network came. Because of that, deep learning. So up to that, learning. So now learning is saturated. We don't want to teach and replicate. So presently learning is saturated, and past 4 or 5 years, generative AI is the trend. No need of learning, no need of training. It is from its intelligence, it is creating. So that is generative AI. After that, LLM, large language models. So under LLM only, this open AIs, ChatGPT, Monica, Gemini, everywhere. If you go to Google, you will be having so many interactive chatbots. Like if you go to Microsoft, it will be asking for Gemini. Like this, there are many open AIs available. All comes under LLM. So now it is moving to reasoning and non-reasoning models. So this is the present trend. So what I could advise is, those who start working with new problems, either you can go for deep learning models, where you design your own model for a particular application, publishing point of view, I'm telling, researcher point of view, or you can try with the generative AI. So generative AI, this is called Gen AI. So this is also basically deep learning model that can create complex original content. So you can have long form text, high quality images. You know, nowadays in television, we see the serials which is completely made by the AI. So that is generative AI. So realistic video, realistic audio, we could see. All humans are created by the AI. In social media, you could see n number of advertisements which is purely created by the AI. Like so, this generative AI will be responding to a user's prompt. When you give a request, it will respond. And this generative models encode a simplified representation of their training data and then draw from that representation to create new work. So this work can be similar but not identical to the original data. You could have tried with your ChatGPT. It is specific to the particular IP. So it will not generate the same content for the same keyword for everyone. So that is what mentioned here. It is creating new work, basically similar, but not identical to the original data. No replication. Basically, this generative AI concept also came from statistics only. It was in mathematics, it is to analyze numeric data, but presently here, based on deep learning, it is used to analyze or generate more complex data. So this is regarding generative AI. Here 3 steps: training, tuning, evaluation, more tuning. So first, training, creating a foundation model, then it go on tuning. So here tuning is important. Previously, while we design systems with convolutional neural network, that is machine learning or deep learning like convolutional neural network, we speak about training like. Here in generative AI, training is a small part. Tuning is the major part. Tuning to adapt the model to a specific application. Then generating the output, evaluate, go for tuning. So step 1, training. You are creating a foundation model. Actually, an advanced version of deep learning where with the basic deep learning concept, you are creating a foundation model. Then you are tuning it to adapt the model as per your requirement, your application. Then generate the output, evaluate, not satisfied, go for tuning, generate, evaluate, tune. So like this, you repeat to improve the accuracy. So tuning is a concept which is introduced here. So, so far I have told you about the artificial intelligence core components. I have told you artificial intelligence. I have told you machine learning. I have told you neural networks and deep learning. So in deep learning, I told you about CNN, RNN, LSTM, and presently I am telling you about the generative AI. So you have enough number of ready-made algorithms available. In the Google itself, you will be getting the basic algorithmic steps. And what I could say is, our AI is going to saturation. Now, it has been developed. AI started before 75 years. And for the last 10 to 15 years, most advancement, it is in the peak. And almost all the algorithms researchers have tried. So it is in the verge of saturation. So better to go for generative AI if you are a beginner in the medical domain, or you can go for the deep learning basic architecture and you can try with hybrid architectures like. So now let us move on to the medical applications. So before going to the medical applications, let us relate the human anatomy and physiology with our technology. So you see, fundamentally human body is made up of cells, which means chromosomes. So this chromosomes consist of DNA, RNA, protein. So it is basically a genetic study. This genetic study happens in the wet lab. Wet lab means with a microscope, biotechnology. But this genetic, if you combine with artificial intelligence, it comes under bioinformatics, biotechnology dealing with the genetics or cells in the wet lab. The same thing if you do with the computer and to be specific, this artificial intelligence, this is having a major scope. So the fundamental particle of the human body is the cells, which consist of DNA, RNA, protein. This DNA is a combination of 4 amino acids, which is the basic unit which determines everything in the human body. And we know there are many diseases which are hereditarily coming from our parents or grandparents. For example, diabetes, to some extent cancer, right? So you will be doing a great service to society if you are taking a DNA and if you are working it with the current technology that have a huge scope, which is normally unfamiliar among the computer engineers. So that is dealing with the fundamental part of the human body. Then come to the chemical composition of the human body. Human body is made up of muscles. Combination of the tissues only give rise to organs. So similar tissues join together to produce organs. For example, if you see the brain tissue will be very soft. So that is having one specified characteristics. Heart is another organ where its tissue is of different nature. Skin is the largest organ in the human body, which is having a different muscle. So like organ wise, you can go for analysis. So when you come to that organ, you can analyze 2 types of signals. You can analyze it in 2 categories. One is you can take it as a signal. Other one is you can take it as an image. So you see, when you consider the vital parameters of a human being, temperature, pressure, respiratory rate. So these are just seen to check whether the human is alive or not. Okay. Apart from that, if you want to check whether your heart is functioning normally or not, everyone knows you analyze with the ECG signal. Okay. So what is ECG signal? Electrical impulses created in the heart. So you have the mechanism to read those electrical impulses from the heart. You will be connecting leads. There are different lead system and all, and you will be acquiring those electrical signals. And those electrical signals you can analyze comfortably with such type of algorithms. So that is signal analysis. Then coming to the brain again. So your brain is also producing electrical impulses, that is alpha, beta, gamma, theta waves. And in order to study about the behavior of brain, you can analyze the brain signals, which are called as EEG signals. So again, your brain signals can be analyzed. Then coming to the muscles, you have EMG signals. That is electrical signals measured from the muscles. So coming to this medical application, depending on the problem, if you want to check whether your heart is functioning normally or not, it is enough if you go for a ECG analysis. If you want to study the cognitive behavior of your brain, it is enough you need the EEG analysis. If you want to have some neuron function or some muscle function, it is enough you can analyze the EMG signals. So one type of analysis, signal analysis. The first I have told you about the genomic analysis, DNA analysis. So DNA can be dealt as a signal or an image. The second one is our vital organs, heart, brain, etc., which can be analyzed in terms of signals. And now I am moving to the third category, where I need a detailed investigation of my organs. For example, I need to analyze whether there are any abnormal tissue in my brain, or whether there is some water accumulated in my brain. Like in that case, that signal analysis will be an indicator. It can tell you there is some abnormality, and in that case I have to go for an image analysis. So this imaging, we have different categories. Similarly, heart, we can have the image analysis. So now let us move to the imaging. Different type of organs, different type of compositions will be viewed with different types of imaging modalities. For example, if you want to see your bone, okay, your skeleton system, your bone, you have to go for X-ray. X-ray is a imaging modality where you are passing X-rays over the body which penetrate and produce the images. X-ray, advanced version of X-ray is computed tomography. So, bone analysis, you need one type of modality, X-ray CT. Then, if you want to analyze the brain or heart, like, you will be going for another type of modality which is called magnetic resonance imaging. There the basic principle is magnetic resonance, which is called as MRI imaging. Then another type of imaging modality is ultrasonogram, ultrasound scan. So there you will be sending ultrasound, high frequency sound waves, and you will be capturing the images which can be used to check the abnormalities in most of the body parts. Then the baby inside the womb can be analyzed. Then to some extent heart that they'll be asking you to take echo. No, so that is basically ultrasonic imaging. So like different imaging modalities are there. So here comes in medical applications, one, signal analysis, two, image analysis. Then based on that, you have the diagnosis of diseases. Diagnosis of diseases can be either classification or detection. So this too comes under diagnosis. Next, let us go to the treatment part. So coming to the treatment part, drug discovery. This artificial intelligence is helpful for the drug discovery. So when there are diseases, for example, recently we came across COVID and all, previously AIDS and all. So by nature we will be facing many new diseases for which the vaccines or medicines are not available. So research is going on for drug discovery, which is basically a chemical engineering where we can use this artificial intelligence. So next is personalized medicine. So personalized medicine means, you see, assume I am from a different family background. The genetic makeup of me is like my father, mother, my grandfather, grandmother, and I may be prone to certain diseases. And my food, my environment is different. And you assume somebody living in Africa, their genetic makeup, their environment, their food is different. Somebody living in some country like New Zealand, they are different. But what is happening? For everyone, diabetic means this is the medicine. Cancer means this is the medicine. Right? So, this personalized medicine will be person specific. Same disease, for me, the type of treatment will be different. For another person, the type of treatment will be different. That can be achieved easily using artificial intelligence. Then clinical trials. So invention is one part, trial is another part. So there also this artificial intelligence helps. Then prediction. You see, identifying the disease and giving treatment. That is one aspect. You are prone to this disease. So you change your lifestyle. You change your food style. You can postpone the disease. So that is a example for, that is the requirement for prediction. So we need prediction in medical domain. So apart from all these things, nowadays surgery, robotic surgery. So for that robotic surgery, their artificial intelligence plays a major role. And finally, electronic health records. You know, when we go for such personalized medicine and all, we need to track the history of the patient. 0 to 5 years, we'll be going to one pediatrician. Then when we were grown, we will be going to another doctor. For certain disease, we'll go to another doctor. Like the patient record will not be completely available. So patient record is one aspect of electronic health record. The other aspect is the test reports and all. So handling data in a hospital is a major difficulty. Huge amount of data to be handled. So all those comes under electronic health records. So in all these domains, this artificial intelligence plays a major role. So ma'am, how much time I can take?
Ma'am, few more minutes you can take, ma'am.
Okay, okay. So in all these domains, you need the artificial intelligence. So you see, I have explained all this in detail. So whenever you go for an algorithm, you have to establish that model is working better. So in that case, generally you have to find certain parameters, certain standard parameters, and you have to establish compared to the previous method, my algorithm is best in terms of accuracy, specificity, sensitivity, F1 score, area under the curve, that is ROC curve like. So these parameters are common for almost all the medical applications, whether you are doing signal processing or image processing. And the important thing is, I told about the data set. And we all are aware it is not easy to collect the real-time data from the nearby scan center or some X-ray unit. So we all will begin with the data sets available in the internet. For diabetic retinopathy detection, Kaggle DR data set is available. So like for each, we can get the data sets from the internet. And future research directions. Nowadays, explainable AI is coming. It is useful in making models interpretable for clinicians, that is doctors, and federated learning, collaborative model training without sharing patient data. So patient will not like their data to be shared to everyone. So here in this medical application, data security is also a major issue. So federative learning comes here, multimodal data fusion, which means fusion means combining imaging, genomics and test data. This is useful in genetic data analysis, DNA analysis. Then edge and cloud AI is useful in healthcare. And nowadays, IoT devices are connected together. Then digital twins, patient-specific simulation models for predictive medicine. I told that patient-specific treatment. So there this. And the most important thing is now quantum computing is coming. It is just entering the field. So we can go for quantum machine learning also, but that is not realistic now. Quantum computers are not available yet. So quantum computer is a different form of computer, different technology based on quantum physics. So after quantum computers coming to market only, these algorithms can be implemented, but people started working on it. So this is also a new field. Now, if you see the future AI milestones, artificial general intelligence. I told in the beginning, we are yet in the narrow AI, and the general AI is acquiring human intelligence. and the super AI is beyond human intelligence. So we had only narrow AI, we have now only narrow AI. So next is moving towards the general AI. Then quantum AI. So as I told already, we are in the classical computers. Once quantum computers came to market, this quantum AI will be in real time. Then this is a singularity. This is a hypothetical point in the future where AI surpasses the human intelligence. So this is about super intelligence, super AI. And the important thing I want to mention is regarding the publications. There are many good free journals available for publishing biomedical applications. So, and most of the journals are publishing free of cost. They are having good impact factor. And I'll just mention this. The recently, one of my scholar have worked with digital breast tomosynthesis, that is DBT. This is a new type of images. Basically, this is a 3D image. In pre-processing, this is converted to 2D images, and then we can apply the artificial intelligence for this. So we have taken this DBT and we have applied the deep learning. We applied ResNet and we published one paper in the Q1 journal, that is a scientific report, and another one paper in the Q3 journal recent. So like this, if you are interested in publishing in high quality journals free of cost, you can go for this medical domain applications with the deep learning. So I have so many publications in Q1 journals, and this one I told MRI here, breast lesion segmentation, only segmentation problem we have taken, and this is published in elsewhere with impact factor 8.8. Same MRI image with deep lab V3 plus algorithm in biomedical signal processing control, impact factor 6. Like then another one paper in International Journal of Imaging Systems and Technology, Wiley. So all these are high quality journals we published free of cost. Then another scholar worked in biomedical image. She worked in EMG signal analysis. She also published in Q2 and Q3 journals, all free of cost only. So another one scholar who completed, I think 3-4 years before, she has taken heart image. So this also normally untouched. So people will be going for MRI, CT, like cardiac magnetic resonance imaging, CMRI. So heart is a very difficult organ to analyze. In the heart, if you take the image, you cannot separate the ventricle. So you have the left ventricle, right ventricle. You are taking the image from the front, over the chest, So the ventricle, the back portion of the heart will be hiding behind. So segmentation in cardiac magnetic resonance imaging is a very peculiar problem, which is having a great significance. And if you deal it with artificial intelligence, you have the major chance of publishing in very good journals. So this is from my side. So with this, I'll stop my presentation.
Participants, if you have any queries, you can post now in the chat box. Ma'am, there are a few questions in the comment section, ma'am.
I'll check. I think all are general questions. Can generative AI can be used in medical imaging? So actually generative AI is coming now. We have to analyze, we have to go for the survey, and we have to start working. So far I do not have a experience of using generative AI in medical imaging. So tuning, it is a part of generative AI. Hyperparameter tuning is already available. LLM can be applied. For working on research, can we use Gaggle data sets? Is it recommended? So data set, one thing is availability. Coming to data set, one thing is availability. You will be taking, when you come to biomedical application, you will be deciding whether you are going to work on heart image or brain image or lungs image, like, or endoscopic image, like. Then you will be searching the data set. So for few organs, there will be readily many data sets available. For few, there will be a scarcity of data sets. That is one part. The other part is, while starting your research, literature survey is the important parameter. Ultimately, you want to publish your result. So, while you publish your result, you have to establish for the same data set what is worked already. You applied the algorithm and your algorithm is superior. Otherwise, the reviewer will be asking, the existing literature is for so and so data set. What is the result of your algorithm for that data set, like? So we cannot say this data set is good, that data set is good, like. Selecting a data set depends on the literature survey as well as the availability. Fission transformers. I'm not familiar with that. Actually, nowadays, whenever we submit the papers, they are asking for real-time data. And if you start your research, it is better to collaborate with some hospitals. It is a win-win situation for both of us. We'll be developing some algorithm. So if you are willing to add them as co-author in your publication, they'll be willing to help you. And the other thing is, some algorithm will work well on the data set. And if you come to the real data, they may not produce that much accuracy. So you will be having the advantage of comparing the results for the existing data set as well as the real-time data. So that normally reviewers will appreciate. Cancer disease detection. Actually, I have my PhD is also in cancer disease detection. I have analyzed DNA and my scholars are also doing that. So you can contact me over email. I'll share my papers. I think I have answered the questions, ma'am. I'll share my email again.
Thank you, ma'am. Thank you, ma'am, for your highly informative and insightful session. Your expertise and clear explanations added great value to our FDP, and we truly appreciate your time and contribution. Thank you, ma'am.
Thank you, ma'am.
Now that the first session of day one is over, let us begin the second session by inviting our resource person, Mr. Sai Satish sir, who is an young entrepreneur, founder and CEO of Indian Servers. Also, he is an administrator of Andhra Hackers, top hacking awareness forum in India. He's a cybercops trainer, author for best-selling book called Hacking Secrets, and he's a renewed ethical hacker and cybersecurity expert. He's a TEDx speaker, and thousands of college students and professionals get benefited by his lectures, which are delivered at IITs, central universities, IIMs, 350 plus engineering colleges all over India. He has delivered more than 3,000 talks on various trending technologies, and he has been specially invited to the Jharkhand Entrepreneur Summit, Global Entrepreneurship Summit. Along with corporates, he has trained many central and state organization employees. He has worked as Microsoft student partner, corporate .NET trainer, and he was interviewed by many national and regional news channels like Aaj Gone, ZTV, TV9, NTV, Enadu, Sakshi, etc. He was rewarded by IAS officers for pen testing on government sites, which helped them to improve security and safe transactions. And he is a recognized forensic investigator. I welcome you, sir. Without
Yes,
any
thank you,
further delay,
madam.
we hand over the session to Sai Satish, sir.
Thank you, madam. Yeah, hi all. Namaste. Myself Sai Satish, CEO of Indian Servers. Today we are going to discuss about medical imaging, and we are also going to discuss about LLMs. Okay, so computer vision is one of the branches of artificial intelligence. We are going to use computer vision to detect the abnormalities and normalities in the images. After that, we'll discuss about VLMs. After that, we'll discuss how these will identify the normal images and abnormal images. Yeah. How many of you joined from your laptop? Please go to reactions, raise your hand. I need a couple of volunteers to do this activity. Though, how many of you joined from your laptops? Because I want you to do it practically simultaneously with me. How many of you joined from laptop? No one. Okay, just raise your hand. Just go to reactions, raise your hand. In more, you can find that option. React. In the React, you can find. Okay. I need one volunteer. Let me lower all your hands. Who wish to be volunteer will make you to share your screen. Who wish to be volunteer? You have to switch on your web camera for some time. Who wish to be volunteer? Any one participant, please. Just respond in chat box. We'll make you as co-host. We'll make you as co-host. I need one volunteer. One volunteer is enough. Yeah, please respond. Yeah. Yes, Satya, need to switch on the web camera. Shall we do it? Yeah, please make Satya as co-host for some time. Yes, Satya, please share your screen. Yeah, all of you, please do this activity in your laptops. Yeah, Satya, please share your screen. Madam, can you make Satya as co-host? Yeah, fine. Yes, the first one, what you have to do is, all of you please do this activity. Just open Google. There are three important things we can do on images. Okay, the first one is classification. Second one is object detection. Third one is segmentation. These are the three things we can do on images. Few more things are there like pose detection and few more things are there. First, we'll see the classification. Yeah, Satya, please share your screen. Satya, can you share your screen? Yeah, please go to Google. Search with the word called Google Teachable Machine. I think, yeah. Just search with the word called Google Teachable Machine. All of you, please do it simultaneously, parallelly with Satya. Google Teachable Machine. Teachable Machine. First, we'll discuss the first concept called image classification. What is image classification? For example, we are going to identify whether it's a cat image or dog image. We are going to train a model and we'll see how it will detect. Okay. Yes. Open the first one, open the first link and log in with your account. Yeah. Click on get started. All of you do it parallelly. Yeah. Select image project, standard image model. Satya, can you unmute yourself once?
Yes, sir.
Yeah. Can you get 3 objects? Pen or mic, or if you have mobile phone, just
Yeah,
get 3 objects. Water
I have to
bottle,
download from net, sir.
not from net, at your home. Get it from your home.
Yeah, sure.
Yeah, one water bottle, one
What?
mobile, and anything, one more object.
Yeah, I got it, sir.
Yeah, 3 objects we need. Then did you get 3 objects? Any 3 is okay. Your
Yeah,
ID
sir.
card, anything is okay. Okay. What you bought? What are the 3 objects you bought?
Adapter,
Okay.
headset, and my phone.
Okay, fine. Just rename the class 1 to the first object name.
1 second, sir. Here I have to go.
Yeah, class 1 is there, right? Class 1. Just click on that pencil icon. Yeah, rename the first object. Set the first object name. Yes. Second class 2. Just create the second class.
1 second, sir.
Okay. Add the third class. Okay, fine. Now click on web camera of the headset.
1 second.
Okay. Choose allow. Yeah, show the headset. No, don't capture the pictures. You should show the headset first. Delete those 2 pictures.
Yeah.
No, wait. First, delete those 2 pictures. Okay. Now show it. Use your other hand. Then click on hold to record. Just click on it. You have to capture on 200 pictures. Yeah, show various sides of that adapter headset. Bring that near to camera. 200 pictures we need. Just click and hold. Click and hold. Don't release. Just click on it. Don't release the button. Okay. 80 pictures, 100 pictures. Now you have to capture on 200 pictures. Okay, done. Now come, stop that. Come back to, just hold your phone in your hand. Phone for phone. Yeah, click on web camera. Hold phone on your hand. Yeah, scroll up slowly. We need to capture 200 pictures. Just check the count. Scroll up. Scroll up so that you can see the count. Yeah, 24 images. Now you have to capture around 200 images for phone also. The concept is image classification. What is classification? Is it dog or cat? Is it male or female? Is there cancer or no cancer? Image classifications. Okay. Okay, done. 200 pictures done for that. Now move to the third one. Hold the adapter. Again, it looks like headphone. It looks like headphone. Okay, do
Okay,
one
sir.
thing.
I'll
Remove that
choose some other thing.
Yeah, just take some other object. Being a human, I'm confused. Okay, fine. You can take that one. Yeah. $200 pictures for them. Hope my audio is clear. Please acknowledge.
Yeah, clear, sir.
Okay. Done. 200 pictures done. Now just click on train model. Here we are using a library called TensorFlow. Just click on train model. Within 30 seconds, a model will be ready which can classify whether it is a bottle or the other objects like adapter, mobile. Okay. Training will be started in few seconds. Within max of 30 seconds, the model will be ready. How many of you are doing parallelly? Please do respond chat box. Click on wait. Don't
Sir, it
exit the
is
page.
showing this page is
Wait,
not.
click on wait. Wait.
Okay.
Yeah, how many of you are doing parallelly? Oh, perfect. Within 10 seconds, model will be ready. Within 5 seconds, model will be ready. And model is ready now. Yes. Yes. Now, no, don't export the model. Just click on that pop, close it pop-up. Export. Yes, click on close it pop-up. Now show headphones. Now see the output. In the output, you can notice something. Yeah, bring near to the camera. Bring that adapter near to the camera. It is showing, no, it got confused. Okay, somewhat headphones is getting much. Now show phone. Yes, it is
100%.
showing 100% phone.
Yeah, fine.
Now show, click on bottle. Yes, it is detecting bottle as 100%. This is called as classification, image classification. If you take 50,000 images with lung cancer and 50,000 images without lung cancer, obviously it can detect in a new image whether it belongs to cancer image or not. This is called as classification. Yes, please come back. Do you have any children at your home, madam?
Yes, sir. They are out.
They're outside. Okay.
Yes, sir.
Can you ask them to come, because this small post project is also we can demonstrate on the images, because our task is AI images.
Okay.
And later we are going to discuss about medical based images. First, let us see what more things we can do on images. Earphone cases, we have to add more images. No, it is not considered 50 images, minimum 200 images. I'm asking, the more data set, the more accuracy, the perfect data set and proper images, the more accuracy will be. Not 50 images, minimum 200 images. Vivek. Yes. Yeah, please come back to Google Teachable Machine. Homepage. Yeah, invite your kids also. Invite children.
Sir, they went
I
out,
think,
sir.
okay, not possible now.
Oh. Yes,
Fine,
sir.
fine. We'll take another volunteer
Yeah,
then.
sure.
We'll take another volunteer. I need one volunteer who have kids at your home. How many images model taking for training out of approximately all the six? What are the data set we are giving? All the images it will take. Right now we gave around 200 images per object. All the 600 images it will take. Yes, any volunteer who has kids at your home, children at your home, I need one volunteer to demonstrate one more concept called post project. Post project. One volunteer, please. Raisa, just do respond in chat box. We'll make you as co-host. Yes, yes, Kusum. We're making you as co-host. Please share your screen. Invite your kids also. Please make Kusum as co-host. Yes, Kusum, you're co-host now. Please share your screen. What about the MLDL model it is concerned? It is a deep learning model. TensorFlow is a deep learning model. It is TensorFlow. Obviously, based upon the image size and total number of images, it takes some time. At last, at 9 o'clock, we'll start Q&A. I have to demonstrate few more. Once it is done, we'll go ahead with Q&A. Yeah, Kusum, please share your screen, your co-host now.
Sir, can you see me?
We can't see you. Please share your screen once. You can share your screen.
I have.
Just click on share screen. Yes.
Yeah, it's visible?
Yes, it's visible now.
Okay.
Yeah, just again open Google Teachable Machine.
Yeah.
Yeah, open this.
Yes.
Yeah, the first task is done, right? Okay.
Yes,
Now
yes, sir.
come to Teachable Machine again. Homepage of Teachable Machine.
New project?
Yeah, new project. Now select pose detection. Close the first tab. Not required. First tab. Just close the first tab, which is classification. Yes, leave that. Now
Okay.
select pose project.
Post project. Okay,
Yes,
sir.
pose project. The pose project here will show you different type of poses, how your poses are. Just class 1 Namaskar. Just mention class 1 Namaskar. Where are you from?
I'm from Bangalore, sir.
Okay, Bangalore. So in Bangalore, you say Vanakkam, right?
Yes, sir.
Yeah, Vanakkam.
Sir, we have moved in here 15 years back before.
Okay, no problem. Vanakkam. Namaste, Namaskar. Okay. Now class 2. Just say hi. Hi pose. Third class, suggest one pose. Ask your kid, suggest a pose from your kid. Ask what are the poses she plays. Like one more pose.
What pose? It's time. What do you want to post? Badly.
Double salute. Okay, salute. Salute. Salute pose.
I think, sir, there's something wrong with this. It's not visible, sir.
Okay, now it's visible. Yeah,
Yes,
click on
sir.
web camera for Namaste. Yeah, only your your kid should be visible.
Yes, sir.
Yeah, switch on the lights. You come out of frame. You come out of frame. Make sure only your kid is visible. Yeah, what's your kid name? Chill.
Okay, sir.
What's your kid name?
What should we do?
Yeah,
Bianca,
please.
sir.
Priyanka. Yeah, Priyanka, just
Bianca.
Bianca.
Sir, it's
Okay.
Bianca.
Do Namaste.
Bianka.
Bianca. Okay, new first time I'm hearing this word. Okay. Hi, Bianca. Which class?
Hi.
Which class are you studying?
Fourth.
Fourth class. Do you like
Fourth.
AI?
Yeah.
What is AI?
Artificial intelligence.
Very good. From now onwards, if anyone asks you what is AI, from now onwards, do you know what you should say? AI is a program which can mimics human brain or which can simulates human mind, human intelligence. A software which can simulate or which can mimic human intelligence is called as artificial intelligence. Done?
Okay.
So what is AI? Any
Uh,
software which can mimic human intelligence is called as AI.
AI.
That means it can act like human. It can simulate. It can mimic the human intelligence. Done? Okay. Do
Yes.
namaskaram pose. Do namaste pose. Okay. Go a little far from camera. Make sure those blue lines matches with your hands. Perfect now. Okay. Okay. Make sure right hand also matches little front. Little front. Come front little. Yes. Hold on. Right.
Dots are there.
It could not able to detect the right hand. Yes. Fine now. Fine. Just capture 200 pictures for this pose also. There is some issue with the right hand. So the data, we are not feeding properly. So we cannot expect accuracy for Namaste pose. Okay. Anyways, give it a try. Let us consider that as one kind of pose. Yes. Hold to record. 200 pictures we need. Okay, done. Now high pose. Now high. Just
Good, yeah.
yeah, come middle of the camera. Okay, perfect. Keep that left hand little more aside. Some distance, some more distance. Yes, perfect. Enough. It should be in the same frame. Yes, hold to record. 200 pictures again. Hold to record 200 pictures. Yeah, Umarani, just open Google Teachable Machine website. There we just saw image classification. Now we are seeing pose detection, human body pose. Last time one 9th class student made yoga poses with this, yoga poses. A guiding app, an AI app which can guide people with yoga, whether you are right or not. Yes, click on hold to record now, salute. Perfect. Okay, salute. 200 pictures. This one take around 1.5 minute for training. Image classification takes around 30 seconds. This human body pose takes around 1.5 minute to get trained. Both are using TensorFlow. TensorFlow, PyTorch, these are very, very popular image related libraries for deep learning. All this comes under deep learning. Yes, please click on train model. In the data set, there is an issue because in the first one, we have not trained. There are some mix of salute as well as namaskar. It didn't took properly. Anyways, we'll give it a try. Please click on train model. It takes around 1.5 minute. The model will be ready in 1.5 minute. Okay. Now don't shift the tab. So one more student made poses related to Bharatanatyam. For example, if someone is doing Bharatanatyam, our pose will detect whether they are doing right or not. Such type of things are possible. Before it gets trained, you can ask me questions now. Please raise your hand. I will unmute you. You can ask me questions. We'll see n number of concepts today related to images. We are going to see VLMs also. Please log in from your laptops. We'll do few things practically. TensorFlow and PyTorch, two important libraries. Few more important libraries are there to play with images. Today, VLMs are also available. VLM, Visual Language Models. So we'll discuss those VLMs also. Then where we can use all these things in medical domain also, we are going to discuss. If you wish to ask any question, please go to reactions, raise a hand. We have 30 seconds. In this 30 seconds, we can discuss 1 or 2 questions. Model is getting trained. One college called Potti Sriramulu Engineering College at Vijayawada, those students, do you know what they did? They trained Namaskaram pose and they have exported the model. They deployed the model in Raspberry Pi. They added a camera to Raspberry Pi kit and they placed that particular model, that particular Raspberry Pi kit inside Vinayaka. Last time at Vinayaka Chaviti. If you come and just do Namaskaram to Vinayaka, automatically it will say Dirghashman Bhava. So such type of things those students are doing. So it's up to you how you're going to use this post project. Many things are there. No, instead of Raspberry Pi, you can deploy anything, any edge device. Even you can use mobile also. Yeah, it takes 30 more seconds. Meanwhile, if you wish to ask any questions, you can ask.
Sir,
Yeah.
will this when we are uploading the images, will this work with any kind of a data set that we have?
This is purely for images.
Okay,
TensorFlow mostly support most of the different type of images.
okay. So what I mean is like the medical images, what we have.
Yeah, medical images also you can try.
Okay.
After a few minutes, we are going to see different type of data sets related to medical domain. Okay. Yes. Now it is done. Just invite your daughter.
Okay. Bianca, please.
Remember, the data set is not accurate here. We'll get surely some mistakes. Bianca, just say hi. Be center in the frame. frame center. Okay. Salute. Namaste. Okay. Hi. Salute. Perfect. Are able to read it, Bianca?
Yes, sir.
So what you are going to say to your friends tomorrow at your school? Are you going to train them on this?
Yes.
Okay. What is this website name?
Teachable
Google Teachable
machine.
Machine. Okay. Even fourth class kids also can do this. Not a big task, right?
Yes.
Take screenshots and tag me in LinkedIn. Do you know my name?
Sai Satish.
You're reading, right? Okay, good. Okay, Bianca, all the best. Thank you.
Thank
You can
you.
close it, madam.
Yeah, thank you
Now you
so
can
much,
stop
sir.
sharing your screen.
Yeah, I think so. Indeed, she has really enjoyed this. Thank you
Okay,
so much.
thank you. Please stop sharing your screen. We'll go to the other one. Now, the second one, okay, one few more things are there related to the same images. The second one is, even it can figure out your hands also. Search with a word called Media Pipe Studio. Media Pipe Studio. Please stop sharing your screen, madam. I'll share my screen now. Yes, hope my screen is visible. Please acknowledge in the chat box. Hope my screen is visible. Please acknowledge the chat box. Okay, perfect. So all of you do it simultaneously with me. Now we are going to build a simple model which can detect brain tumor, or which can detect broken bones, or which can detect n number of things. Almost most of the things it will detect. Okay. Very, very important concepts we are going to discuss. Open the website called roboflow.com. Roboflow.com. Open this website, roboflow.com. Just get started. Sign in. Sign in with your account. Second. Yeah, 1 second. Just go to this website and log in. If you don't have account, just sign up in that account. Yes. Now, this is one of the best website where you can host your data sets, where you can find other data sets, you can train the model, and you can deploy the model also. Almost A to Z, end to end, you can do with this particular website called roboflow.com. How many have done signing into this website? Please do respond chat box. How many have done logging in? Only 4 members. 5, 6, 7, 8. Okay. First, after signing up, there is a website called universe.roboflow.com. Same website, universe.roboflow.com.
Sir, which plan we
Roboflow.com.
have to choose, sir?
You can
Sorry
choose
for
anything. Yeah, you
interruption.
can choose anything.
Yeah, thank you.
If you wish to pay, go for paid version. If you want to for free, go ahead with free personal version. Personal. universe.roboflow.com. Here almost 10 lakh data sets are available. 10 lakh data sets. See, 500 million plus images are available. Not just one or two. 10 lakh plus data sets are available. And millions of images are available. Millions of images. 1 million data sets. Let me show you a small one. Your data sets related to brain tumor, lung cancer, almost n number of things are available. Scroll down, just explore the concept called explore, just see the popular categories. Just select the concept called medical category. Medical, where are you? How many are able to see medical? Are able to see medical? Just open that. Now, if you scroll down, you can select any number of things. Yeah, medical, just open universe.roboflow.com. Universe.roboflow.com. Open the popular categories, then select the category called medical domain, medical category. There you can see again some thousands of data sets related to medical domain. With this data set, you can detect cavity, tooth cavity. Something whether the person is wearing eye protection or not. Some cells, some liver disease, almost 4,000 images. See here, object detection. Now we are going to discuss object detection, not classification. What is the difference between object detection and classification? For example, if you take this image, if you say whether it is cat image or a dog image, it is called as classification. Where is the dog? Where is the cat? What are the coordinates? Exactly from which XY coordinates? It starts and height and width. If you calculate like that, it is called as object detection. Object detection is different. Classification is different. Classification means either this or that. Object detection means where is the cat? Where is the dog? That comes under object detection. Okay. Now, here, stomata cells, ACL X-ray, n number of brain tumor, some monkeypox detection, some bacteria detection. See, let me know which data set you are selecting. Please respond in the chat box. Which data set you are selecting? Respond with the data set name. Respond with the cavity, brain tumor, brain, bone fracture. Okay. I'm expecting from everyone. Breast cancer detection. Okay. More. Okay. I'm also selecting the simple one, cavity detection. Different type of images will be there. MRI image, CT scan, X-ray. You can choose anything. This is a plain camera RGB image. Only thing is we need proper labeled data set. Labeled data set is very, very important. Open the data set. Done opening the data set. Okay. Balu, you're saying cancer, but which cancer? Is it breast cancer or liver cancer or lung cancer? Or what kind of cancer? Blood cancer? So which data set is it? Okay. Now look at the screen once. After opening data set, left side, you can see data set here. Use this data, download this data set. Click on download this data set. First, see it as a magic show. I'll give you some time to practice. Click on download this data set. Again, click on download data set. Download data set. Continue. Download zip to computer. No, click on show download and select format. Select format. You want with coding or without coding. Within few seconds, you can make it. Even 5th standard kid also can try and model just in 15-20 minutes. That's it. Model will be ready. You want with coding or without coding? Auto ML or ML? Please respond chat box. Just within 10 minutes, we can do it. Which one do you want? With coding or without coding? With code means here you have to select YOLO. YOLO, these versions you have to select with code. Okay, YOLO 11 or 12. There are few things you have to fine tune the parameters. You have to tune the parameters. That is different task. But if you want to make it very simple, select Ultralytics for some time. Select Ultralytics Hub. Very simple, this one. Select format Ultralytics Hub. Okay. Just click on download dataset. Download dataset. I'm showing you again. Dataset. Download dataset. Download dataset. Continue. Show download code. Continue. Select format. You have to select Ultralytics Hub. If you want to code, you have to select any of these versions, YOLO 11 or 12. If you don't want to code, everything automatic. Select Ultralytics Hub. Select that and click continue. Wait for a few seconds. Yes. Now it is navigating to Ultralytics Hub website. Ultralytics Hub. Here, log in with your Gmail. First, sign up with your Gmail account. I already signed in, so I'm going to log in with my Gmail account. First, see it as a magic show. We'll repeat. In one of your systems, we'll repeat it. First, see in my computer. Continue. First, see in my computer. I'll guide you in your computer. First, see it as a magic show. Yes, I'm logging into Ultralytics. I'm going to download the data set now. I'm downloading the data set. Now click on train model. Download the data set. Click on train model. Yeah, first see in my computer. After that, you can do it parallelly. First, see it as a magic show. Then I'll make some of you as co-hosts. You do in your computer. I'll guide you through voice. Yes. Here, I want to select YOLO. I'm just mentioning some project name. Teeth. Okay. Model name V1, version 1. Here, YOLO 11N is there. N for nano, small version. S for small. M for medium. L for large. Okay. Here, Nageshwar, I already told you that is a deep learning model. That is TensorFlow. TensorFlow. I already told you that one. Yeah, we'll have Q&A after some time. First, let me finish this. From 9 o'clock, sorry, 9:10, we'll start discussing Q&A. Select N for nano. The accuracy of this model will be very less. If you select N, the accuracy will be very less. Speed will be very fast. If you select extra large version, accuracy will be increased. Speed also will be reduced. Speed, see here, that means per second it can test only 2 images, but accuracy increased when you compared with nano version. Okay, I'm selecting nano, click continue. Click continue. Now select Google Colab. Google Colab. Click on open Google Colab. Open Google Colab. Connect to GPU. We have to connect to GPU to train the model. Connect to GPU. Scroll down. Run the first cell. Run the first cell. After running the first cell, in the second cell, you have to replace few things. This cell you have to replace. First cell as it is, you have to run. In second cell, you have to replace with this content. Copy this content and paste here. Paste here. Run the second cell. Now, if you observe, it got connected and training got started. Within 10 minutes or within 20 minutes or within 1 day, based upon the total number of images and the total number of epochs you set, the model will be trained. And model training started. We are still in the first epoch. We have to wait for some time. We gave 100 epochs. Otherwise, you can modify this also. You can modify epoch also. So training started. After 20 minutes, model will be ready. I'll tell you how to inference the model. Inferencing model is different way. I'll tell you how to inference the model after some time. First, start the model. Okay. Now I want one volunteer. We'll do from scratch. Okay, we'll do from scratch. Who wish to be volunteer? One person please raise a hand. We'll make you as co-host. Yeah, Vanita. First, you have to upload the data set in Ultralytics. Then you have to run that particular model in Ultralytics. One second, guys. 1 second, guys. I'll be back. 1 second, guys. Yes, guys. Yes, I'm back. So, first you have to create a data set. You have to upload the images in RoboFlow. Then you have to label that. Then you can train in Ultralytics. I need one volunteer. Who wish to be volunteer to share the screen? No need of web camera now. Kusum or Sacha, any one of you? Will you be volunteer? Yes, please share your screen, Sacha. Doing for the second time from scratch. Look at the screen once. First, what we have to do, we have to go to universe.roboflow.com. Go to that website, universe.roboflow.com. Here, we have to select one data set. For some time being, let us stick to medical images. Scroll down. Yes, that's the right website. Scroll down. You can see list of popular categories. Popular categories. Under popular categories, medical domain will be there. Yeah, same website, RoboFlow. Just here you can see medical. No need to type. You can browse directly. Popular categories will be available. Yeah, scroll down. Just select cavity. Select cavity. Make sure you have minimum 400 images. Minimum 400 images. The more images, labeled images you have, the more accuracy it will be there. But no need to add lakhs of images. Last time Google has trained with almost 1 million. That means 10 lakh eye images. Google got trained related to diabetic retinopathy with 10 lakh images, almost 1 million images. Today, Google trained in 2017, not now. Now, even with 2000 images also, will get very good accuracy because in any AI model, two important things are there. One is a neural network. What kind of neural network you are using? The second one is the data set. These two plays very, very important role. Data set and the neural network. Here, we are using one particular library called YOLO, Y-O-L-O. YOLO full form, you only look once. You only look once. This is one of the fantastic libraries similar to TensorFlow and PyTorch. PyTorch and TensorFlow, superb. After that, YOLO. YOLO also uses PyTorch. YOLO, a kind of wrapper, it uses PyTorch only. Okay, YOLO uses PyTorch and TensorFlow number one. Few more libraries are there related to computer vision. Within few minutes, I'll show you those. You can make a note of them also. I'm going to take two sessions for you. One is today, next week. After a few days, one more session I'll take. In that session, I'll share few more computer vision related concepts. Okay. Now click on dataset. Download dataset. Select download dataset again. Continue. Show download code. Select Ultralytics. That's the best one. Ultralytics format. Ultralytics hub. Right. Continue. Now you'll be navigated to Ultralytics website. Just sign up with your Google account. Sacha, are you faculty?
Sir,
Are you faculty, same college or different college?
sir, different college.
Okay, perfect. Yeah, just select your email account. Continue. Yeah, sign up with your credential. Just share your details, job title and other things. Continue. Yes, now you have to import the data set to your account. Click on import. How many images are there? 418 images are there. Fine. This is worth. Now click on train model. If you want more accuracy, you have to go to extra large, which is X, YOLO X, YOLO 11X. We don't have much time, so we'll select YOLO 11N. N for nano. Select N, scroll down, continue. Click on continue. Continue. Yes, select Google Colab. Copy that code. Perfect. Now open Google Colab from that link. Yes, right side top, you have to connect to GPU. GPU is very, very important for training the models. Yeah, just click on connect GPU. That's enough. No, first, no need of that. No need. Not hosted. Okay, just click on connect up, the direct button. Yes. Now scroll down. Run the first cell. First cell, you have to run the first cell. First cell will import required libraries. Okay, fine. In the second cell, you have to replace everything with the code what you have copied. Replace everything with the code what you have copied. Yes, run the second cell. Yes, training started now. Since only 400 images, it takes around 10 to 15 minutes. By this time, some of you have already completed. Those who are doing simultaneously with me, you might have completed this already. How many have done 100 steps? Please respond in chat box. Those who have done 100 epochs. Epochs is an iteration. Just check the training. Yeah, come back to Ultralytics. It will show you. Yeah, come back to Ultralytics. Click on done. Yes, now you can see the training progress here. It takes around 20 minutes to complete the first task. It's 9:01 now. Within 9:15 or 9:20, 100% training will be done. Yeah. Meanwhile, if you wish to ask any questions, just go to reactions. Now open for questions. Open for questions.
Sir, excuse me,
Yes.
sir.
Yes.
Sir, actually, I lost the thing. So I lost the flow. I've just gone to download data set. After
Yeah.
download data set, what should I
Satya
do?
madam, just stop sharing your screen. You please share your screen.
Can I share my screen,
Yes,
sir?
share your screen.
Is my screen visible, sir?
Not it. Wait for a few seconds. Yes, now it's visible.
Yes, sir.
Yes.
So
Left side, just click on dataset. Click on download dataset.
yes, I have done that.
Yeah, click on that. Download
Click on
dataset.
this, sir.
Again, click
Training.
on no. Again, click on download dataset. No, same. Download dataset. Again, the third option.
This one.
Yeah, third option. Download dataset. Continue. Yes. Now select Ultralytics. In format. Ultralytics.
This one.
Yes, Ultralytics Hub.
Maple. Sir, here I have to use sourcing.
Anything is okay.
Anything is okay, sir. Okay, sir. I have to select import, sir?
Yes, import. Click on
Yes.
train model.
Sorry, sir?
Click on train model.
Train model. Okay.
Mention the project name and version. Then click continue. Select
Sorry, sir?
nano. Just mention the project name. Cavity detector. Project name. Version 1. Model name is 1.
Detection.
Cavity detector. The model is cavity. It will detect the cavity.
This one is fine, sir?
Yeah. Next model name mentioned as something alpha, beta, your choice, anything. Just mention 1. A1. Okay. Anything is okay. Continue. Most of these are real data sets only.
It's
They are not
asking
dummy
me.
data sets.
Okay.
Yeah. Select Google Colab. Yeah. Copy the code. Copy that and click on Open Google Colab. Yeah. Connect to GPU. Run the first cell.
Sorry, sir?
Run the first cell. Run the first cell.
This one?
Execute the first cell. Yes. Now in the second cell, just replace all the content with the content what you have copied.
Okay, sir. So here I'll just delete everything and I'll copy
Yeah,
what.
just replace the content. Replace the cell with the content what you have copied.
And I'll run this again, sir?
Yes, run that cell. Now come back to Ultralytics Hub. It will show you connected. Yes.
Yes, sir.
Click on done. Now model training got started. You have to wait for 20 minutes. The model will be ready. Now let us be back to Satya Madam's system.
Yeah.
And
Thank
we'll see
you
the
so much,
progress.
sir. Thank you.
Yeah, thank you. You can stop sharing your screen.
Yes.
Satya Madam, please share your screen. Yeah, we'll discuss that. Now, within 5 to 10 minutes, we can start. Okay, 55. Now we can start the Q&A. Is there any facility to add any other model other than available models or multi-modal concept? Multi-modal concept, if possible, there is some additional training you can give, like checkpoints will be available. You can add the new data sets to it. You can make it as a multi-modal also. Multi-modal is available, is possible. Yeah, open for questions. Model is getting trained. We have to wait for some time. Meanwhile, if you wish to ask any questions, please go to reactions, raise your hand. We'll unmute you. You can ask me questions. Data fusion or data diffusion? Data fusion I have not worked on. Diffusion models I have worked on. Diffusion models. Hiral Patel. I have worked on diffusion models, but not data fusion. There is no specific. You can combine the data sets. Existing data sets you can combine. Saburabanu, you can combine multiple data sets. Some lakhs of data sets are there. You can combine them. Generally, multi-modal is referred to like text input, image input, text output, video output, image output. Those things can be called as multi-modal. You can combine multiple image-based data sets also. That is also possible. Table data and signals. I have to work on that. Yep, some models are there. If possible, just go to the website called. Very good question, this one. Sabura Banu, please unmute yourself. Sabura Banu. Yeah, please unmute yourself. Sabura Banu.
Yes, sir.
Yeah, what is your exact question?
Sir, actually, take for instance, I want to do work for a cancer patient. So I
Okay.
have images of cancer patient. I want additional details like his age and other complications he's having, so that I want to design or model a. I want to have a multi-model
Okay, I'll show you
deep
few
learning
models.
technique.
Yeah, I'll show
So
you
for
few
that, I
models.
want some data repositories from where I can get for the same patient. I want both images and table of data.
I can show you few pre-trained models where you can fine-tune them. Okay. Madam who is sharing the screen, Satya madam, just open the website called huggingface.co. Huggingface.co. Here some multi-models are available which takes both the text and image as an input. Huggingface.co. Not com, it is co. Okay. Just click on models. Now click on tasks. Yeah, in the first multi-modal, you can see the options here. Image, text, to text. Just click on that second one. Image, text, to text. You can play with this, fine-tuning these pre-trained models. You can play with this, Sabura Banu. Madam, are you there? Banu madam.
Yeah.
Can you see the screen there?
Yeah.
Yeah, these models specially takes both text as well as image as input and gives text as an output. Is it what you are looking for?
So what I am interested is, I want to go for a biomedical multimodal approach for combining data. Take for instance the history of the patient, like what is the duration in which he had the disease.
Yeah,
In
see, that is
addition, I'm
what the
having PET
text
CT
and
images also.
yeah,
So I
text
want
and
to
images you
combine.
want to give as input, and you want output as a text.
Yeah, text or I want to give the severity of the disease. So
Yeah,
that
text
I want.
output.
I am asking whether we have a lot of data repositories like Kaggle, Menly, and
No
all.
specific
So I
repository
want to
for that.
know whether
No,
there
no.
is any repository which is going to have combination of images, text, or table data, signals, and all for a single patient.
Okay, for that specific data sets, I'll share some repositories.
Yeah, I
You have
want
to check
to
there.
get some
But for
information
when it comes to
regarding
the pre-trained
repository
models, when it comes to
where
the
I can get.
1 minute, madam, let me answer. If you want to play with the pre-trained models, this is the list. These things you have to fine tune. Okay, these models are available for fine tuning. These take both text and images. Fine tuning is mandatory. Okay, if you want to get, I don't know whether that specific data set is available or not. I'll share a couple of websites where you can find some medical based images. Okay, one of the important websites is this universe.roboflow.com. Mostly images data set you can find. If you want to combine, there is one more website called grand-challenge.org. Grand-challenge.org. .org. In this website also some hundreds of medical, especially medical based images are available. Especially medical based images. If you scroll down, you can see most of us already playing with this US based data sets, and Indian government also has shared some data sets, not medical data sets, but other data sets Indian government also shared in Smart India hackathons and other things. This particular website, grand-challenge.org, is specially for medical. Plenty of data sets are available, both with combo, multi-modal data sets are available. You can check with this.
Sir,
If it is not there, we have to create the data set.
excuse me, sir.
Yes, madam.
So these are all raw data sets?
Labeled data sets.
Okay.
Most of them are labeled data sets.
Okay. Okay. So, like what, like right now I'm working on something. So, is there any specific website where it consists the DNA sequencing of a particular like image is there?
DNA sequencing, not with images. Generally, for DNA, there
Yes,
is
sir.
1,000 human genome project is there. Search with this word 10,000 or 1,000 human genome project. Search with this word human genome project. Some websites are giving around 80, 85 things are there. Yeah, search with this word human genome project. Around 10,000 or 1,000. Yeah, human genome project. Hit enter. Here some open genome datasets are available. Some are labeled for biomarkers are already also labeled for cancers. For few things, cancers are also labeled. Biomarkers are there for this. And Indian government also started one more project called Phenome Project. They capture all the genomes of female, especially young children, and they'll detect whether cancer is there or not. That project name is Phenome Project in India. Okay, just search with this word. Also, I wrote one particular book, Artificial Intelligence in Medical Domain. Search with this word, Artificial Intelligence in Medical Domain by Sai Satish. In that, I have shared plenty of resources related to DNA also. Artificial Intelligence in Medical Domain by Sai Satish. In SlideShare, I have shared that book. In our LinkedIn also, I have shared that book. Otherwise, in our website called amersociety.com, I have shared. Yeah, second, just go to the second one. Second link, Amer Society. That is our website. Yeah, this is the book. Here I have shared the book link. In our website, you can download, you can see thing related to. Scroll down, there will be a link. Yeah, click on download. You can download that. Now hit Control F, select genome. Yeah, scroll maximum 1 second. Just zoom this, the third index page. Yeah, Harpit, breast cancers, broad dataset, I don't know. Maybe available in RoboFlow. Once check that one. Yeah, scroll up, scroll up. Just show the index page. Yeah, human brain projects, AI in radiology. These things you can give it a try. This is almost a 3 years back book. Now it multifold because of drug discovery, AlphaFold. Things got multifold. This is 3 years back book. Still, plenty of resources we have added in this book. You can give it a try. Yes, open for questions. Madam, check how many epochs done. 3D data set is not that much easy, Harpit, but there is one particular website for especially handling 3D. The website name is supervise.ly. Just open this website, madam. Satya, madam. Supervise.ly. For 3D based one, supervise. Not supervised. It is supervise.ly or supervisely.com. Yes. Yes. Hit enter. This is a website specially for 3D annotating 3D images. Supervisely. No, you cannot expect for free, Harpit. You have to pay for that website. You cannot expect free things for free because they are investing a lot on servers. We cannot expect things for free. Yes, come back to Ultralytics. Back. Check how many epochs are done. Come to Ultralytics website. Ultralytics, yes. So if you scroll down, you can notice 100 epochs are done. Now you can see the result, MAP, mean average precision. Generally, it should be 95% plus. Then only you can see the accuracy is less than 80%. But anyway, somewhat okay. No problem. You can give it a try. Just download any image related to cavity. Then just download any cavity tooth from Google. Harpreet, if possible, in next session, we'll see the source for the data sets. I have shared one book, right? In that, I have mentioned the source for the data sets. More than 10 different sources. Very, very important website. Make a note of this important website. Datasets.google.com. Datasets.google.com. That itself is a datasets search engine. Datasets.google.com. This is a datasets search engine. Almost more. Okay. Search for datasets Google search engine. Search with this word datasets Google search engine. Dataset space Google. Datasets space Google. Yes, hit enter. Yes, dataset search.research.google.com. Please note the URL. Note on the URL. This is the right URL. So just search with this word. You may find it. If you can't find it, just go to hospital. Just go ahead with proper NDA, also HIPAA compliance. Take patient's permission, take ethical committee's permission, then collect the data set, hire any radiologist or any appropriate medical doctor, ask them to label it. No other choice if you can't find data set. This is search engine of data sets. Yes, come back to our Ultralytics website. Yes. Now, did you done downloading any image, cavity image? Yes, scroll up. Just download any data, cavity image. Now let us see whether our trained model will detect the cavity or not. Yes, come back to Ultralytics. Scroll up. There is an option called preview. Scroll up. Yeah, click on preview. Preview. No. Preview. No. Yes. No. Preview. There only. There only. Scroll up. Scroll up. Scroll up. There only preview. Little left. Little left. Yes. Upload that image. Accuracy is less than 80%. We cannot expect 100% accuracy. But anyways, it's going to show us the result. Yes, see, few are identified as cavity, few are identified as normal. The dark blue color identified as cavity, dark blue color. And light green color is normal image. Done. You can deploy the model. Right side top, you can download the model. Right side top, scroll up once. Scroll up. There you can see one option called deploy. You can download this model to PyTorch version or TensorFlow version. Scroll down. You can scroll down. Yes, you can download to ONNX version also. In these models, you can export and you can deploy in Raspberry Pi or in your website. Anywhere you can deploy the model. Okay. That's all from my side for today. In next session, we'll discuss few more concepts. Open for questions. Last 10 minutes. Last 7 minutes. Open for questions. Those who wish to ask questions, please go to reactions, raise your hand. We'll unmute you, you can ask me questions. Manraj, my name is Sai Satish, sir. You can search in LinkedIn. You can find my details. Sai Satish is my name. Open for questions. Please go to reactions, raise your hand. We'll unmute you, you can ask me questions. Anything related to NLP or CNN or cyber security, we can discuss. Yes, Arul Kumar, please raise your hand. We'll unmute you. Two accounts are there, Arul. Which account shall we unmute? Aisha, please unmute yourself. Yeah, you logged in from two accounts, Arul.
Hello.
Yeah, Aisha, madam. Yes, ask your question.
Yeah, yes, sir. I would like to ask regarding the multimodality image fusion. So is there any predefined models or any sites where the models are available?
Yeah, Hugging Face only. Few minutes back, we have seen the Hugging Face. In the
Yeah.
Hugging
Oh.
Face, multi-models are available. You can take image and text as input. You will get the text as an output. But you have to fine-tune them. Q&A is available. DeepSeek is available.
Okay. No, I'm speaking about the models.
Yeah, they're the pre-trained models.
Okay, okay, okay.
Q&A
Yeah.
is also pre-trained model. You can use that also.
Basically, if, even the PET MRI or something like that could be fused.
I don't know that one. I have used
Okay,
Q&A.
I'll just find out. Yeah, yeah.
Okay.
Thank you.
Welcome. Yes. Any other questions? Please go to reactions, raise your hand. We'll unmute you. You can ask me questions. Madam, I think no questions. Over to you, madam.
Thank you, sir. We sincerely thank you, sir, for delivering such an informative and engaging session. Your valuable insights, clear explanations, and practical examples enrich the participants' understanding. We truly appreciate your time, effort, and support. Thank you, sir. We have posted the feedback link in the chat box. Participants, kindly fill the form. I also thank all the participants for your kind cooperation and active involvement throughout both the sessions. Let us meet again tomorrow evening 6 p.m. to have another informative session. Thank you.
Thank you, sir.
Thank you, madam. Thank you all. Bye.
Ma'am? Ma'am?
Yes, ma'am.
Feedback is the attendance link only.
Feedback?
Feedback and attendance link is the same.
Same, yes, ma'am. Just one link.
Okay, thank you so much.
Thank you, ma'am.